Hi everyone, good evening. In our previous session, we talked about the vSphere cluster features. We started with the DRS, DPM, and then HA, and after the HA fault tolerance. And today is the fourth session of vSphere cluster features, and we are going to talk about storage DRS, in short form SDRS. Okay, so and once the discussion is completed, we can do on our home lab. And this is icon for the storage DRS architecture. Storage DRS icon is looks like this. And let's observe our today's agenda. In our today's agenda, we can again same like our previous session. We'll quickly recap our vSphere protection at every level. Okay, what are all the features we covered until today, and also the vSphere load balancing technique. What is a present if within the vSphere? What is the load balancing techniques are available, and vSphere storage DRS architecture. Within the storage DRS architecture, we talk about Datastore Cluster and storage DRS requirements, storage DRS configuration limits, and storage DRS resource management capabilities. Resource management capabilities, we can also consider it as a storage DRS use cases. Okay, and finally we can do the vSphere storage DRS home lab. And this is we are familiar for this in virtual infrastructure challenges and solutions. Whatever the infrastructure size, either it is small, medium, large, whatever the size of infrastructure, and the most common infrastructure challenges we are familiar. Normally, for the to meet our customers SLA availability, we have a HE and fault tolerance. For the load balancing mechanism, we have DRS. For overutilized, we'll go for DRS. For underutilized, we'll go for a distributed power management. And similarly, there is another use case. The main challenges to the customers are vSphere data store performance concerns. There is some data store performance concerns, and also sometime if we have 100 data stores. So for example, if you consider a large organization or medium organization, there is a 4,000 VMs. Even in the tiny organization, 100 VMs. These all the 100 VMs, they will it require a multiple data stores. Few data stores are NFS, few data stores are VMFS, or else some companies they may use a dedicated software defined data stores. Software defined data stores means either a virtual SAN or virtual volumes. So whatever the data stores customers are using, the most common challenges are data store space utilization problems, performance concerns, and also virtual machine VMDK file growth rates challenges. File growth, suppose if you are using a thin disk format, we should also have a keep monitoring the data store status and also the virtual machine disk status. Sometimes some of the virtual machine files, VMDK file growth means either a normal virtual machine VMDK or any snapshot disk files also, there is a file growth. So these are all the most common customer challenges. So in order to address these challenges, we have a third solution, that is storage vMotion. Normally, if you have any data store performance concern on any one data store, we can migrate VM to another ESX, another data store. Similarly, even if your data store space is completely full, the solution is we can do the storage vMotion manually from one data store to another data store. Even VMDK file growth also increases, we'll go for a storage vMotion feature. But the storage vMotion feature is a manual feature. If you want to require a automated feature, that is the storage DRS. And vSphere protection at every level, conceptual diagram, we are familiar for this diagram. Until now, we talk about the DRS, DPM, HA, fault tolerance, and even storage vMotion, we familiar how to migrate the virtual machine from one data store to another data store. So in order to automate the storage vMotion feature, there is another vSphere cluster feature called storage DRS. Okay, we'll focus on the storage DRS today. And vSphere load balancing technique. Before we start the storage DRS, let's try to understand the vSphere level. What is the load balancing technique we have? For example, within the vCenter cluster features, if I want to balance the load between the ESXi host, for manual method, we'll do a vMotion. We can migrate virtual machine from one ESXi host to another ESXi host. To automate the vMotion feature, we'll go for a DRS, fully automated method. So DRS also uses a vMotion technique. Similarly, even in the data store level, in order to balance the load on your data store sizes. For example, in this diagram, easy understanding, we have three data stores. One data store is silver, gold, bronze. Even within this three data store, let's say if you see the diagram, first scenario is the VM is running on it is running on the branch data store. Suppose in future, if the branch data store is full, we have the solution is we have to do a SV motion from branch data store to other data store wherever the space is available. Okay, but this is a completely manual migration using a SV motion, storage vMotion. But when it comes to the storage DRS, the name itself says same like vMotion DRS. Here, only the additional letter added SV motion. Here S means storage vMotion. Here also same storage DRS. The only concept similar like a distributed resource scheduler concept, but only the scenario is it's like a completely data store scenario. For data store load balancing, we'll go for a storage DRS. Okay, so even storage DRS uses a SV motion technique and SV motion requirement, how the SV motion work and all, we are familiar. The same concept is applicable in storage DRS also. But only thing is it's a fully automatic technology. Now we'll deep dive into the storage DRS concept. So before we go into the storage DRS, this is the architecture for the storage DRS cluster. So storage DRS architecture, within the architecture, the main key component is data store cluster. So data store cluster is nothing but a data store cluster is a group or collection of a data store. So even the icon also looks like a group of multiple data stores. So this icon represent as a data store cluster. When we add a data store to a data store cluster, suppose we in this diagram we have within the architecture we have four data stores: data store 1, data store 2, data store 3 and 4. When we add this data store to data store cluster, the data store resources become a part of the data store cluster resources. That means in this diagram we have each data store running with 2 terabyte size. So we have 4 data store, 4 multiplied by 2, and the total data store cluster size is 8 terabyte. Okay, the same point we highlighted here. The data store resources become a part of the data store cluster resources. So when we collect all the 2 TB data stores, it become as a totally 8 TB data store cluster. And the data store cluster manages the resources of all data store within it. So normally in a data store, what is the main components in the data store is we will store the virtual machines, templates, and also the ISO files. But in the data store cluster, how it will balance the resources is it will migrate the virtual machine files from one data store to another data store, but it will migrate only the virtual machines data. That means VMDK files. It will move from one data store to another data store whenever it is overloaded. Okay. Now we're going to talk about how the data store cluster works. So for example, similar like a DRS also one of the cluster feature. While enabling the DRS, we turn on the HE and DRS features. Similarly, while creation of data store cluster, we need to turn on a storage DRS option. Suppose if I turn on a storage DRS option on a data store cluster. When we turn on this data store cluster, it will try to data store space utilization is verified every 5 minutes. So every 5 minutes, it's keep monitoring all these four data stores. Let's say any data store is having a high consumption, or suppose some user is increase the few virtual machines disk size. If when the user is increase the virtual machines disk size, it will impact on the data store size also. If any one of the data store size is completely overloaded means generally the recommended utilization is 80%. If it is over 80%, that is nothing but a data store is overloaded. Data store overloaded, it can be a first data store, second data store, or any of the other two data stores. But whatever the scenario, how that storage DRS work is, if it is identified any data store is overloaded, it will start migrating the virtual machine from overloaded data store to other wherever the resources are available. Suppose data store 3 or data store 4 have enough free space, it's keep migrating the virtual machine. That is the part of the storage DRS. Suppose in this diagram, it's when the data store is considered it as overloaded, immediately it's migrated the virtual machine from data store 1 to it's migrated to the data store 4. Okay, this is not like a one time process, it's always the continuous process. It's keep monitoring and it will migrating the VMs. Okay, so this is like a completely automated storage vMotion mechanism. Not only for the space utilization level, even storage DRS will also monitor the IOPS. IOPS means input output per second. Even every virtual machine have a some default IOPS. Normally in our home lab we are using a unlimited IOPS, but in the customer scenario, some customers they will configure a dedicated virtual machine IOPS. This virtual machine IOPS we can configure on a VM edit settings. For example, let me connect to our lab system. Let's say in our lab system, we have a multiple virtual machines. We have FTVM, some VRA VMs and Windows 10 VM. Any virtual machine, if you select, go to the edit settings. Within our edit settings, just expand the hard disk. You will find a virtual machine limit IOPS. So input output per second. So default in our test lab, we selected as a unlimited, but in the production scenario, it can be a custom. You can set the limits like a minimum 60, maximum value is this one. But normally they will customers may configure test VMs. Every virtual machine hard disk default 1000 IOPS and the production virtual machine 10,000 IOPS. And the 1000 is for your test and development you may configure as a 5000, and for production VMs you can configure as a 10,000 IOPS. So like that we can limit our disk capacity IOPS. So it will also monitor the disk IOPS. In case of any of the data stores having a more IOP load, during that scenario also, it will initiate the virtual machine migration from one data store to another data store. Suppose if you have 100 data stores in your data center, even for 100 data store, it is very difficult to monitor every time and doing a SV motion activity. So in order to perform that, in order to face that challenge, the only recommendation from VMware is just configure a data store cluster. But this data store cluster IO load it will monitor for every 8 hours, and for the space utilization it will verify for every 5 minutes. Okay, so this is the data store architecture and how it will work. And the SV motion functionality we are familiar how the VM is migrating from one data store to another data store. Now let's talk about a storage DRS requirements. So storage DRS requirements, as we aware, it's a vSphere feature. So that means we require a vCenter server latest version 7.0 or any of the later versions like 7.0 update 1, update 2. Maybe in future VMware may release a say any of the other 7 series of versions. And similarly, we require ESX also to configure a storage DRS. And vSphere, VMware vSphere Enterprise Plus license is required. Okay, in our later classes, I will explain clear about the all the license features difference, but understand that storage DRS is one of the Enterprise Plus license feature. Okay, and if you have a standard license, this feature will we are unable to configure. So only for the Enterprise Plus license only we can configure storage DRS. And the data store supported. As we are aware in our vSphere environment, we have a 4 types of data stores. We can configure NFS, network file system, virtual machine file system. Even VMF is supported for a local storage, FC SAN and iSCSI SAN. And we can also configure additional virtual SAN, virtual volumes. These two are the software defined data stores. So all these type of data stores, you can able to configure storage DRS. And the data stores which are shared across multiple data centers are not allowed. So the requirement is if you want to configure data store cluster with storage DRS feature, we can configure only within a data center. It cannot be shared to the other data centers. Okay, and NFS and VMFS data store cannot be used in the same data store cluster. This is also one of the condition given by VMware. If you want to configure a data store cluster for your supported data stores, I given one example in the below diagram. You can create separate data store cluster for NFS data stores, and for VMFS data store, separate data store cluster, and virtual SAN separate cluster, and virtual volume separate cluster. It cannot be mixed with a different flavors. Okay, and even if within the virtual machine file system, if we have a fiber channel VMFS volume, and if you have a iSCSI VMFS volume, VMware recommend that no need to configure iSCSI VMFS volume and FC volume on a same data store cluster. Better split it into a two data store clusters. For fiber channel data stores, one data store cluster, and for the iSCSI data stores, you can create a separate iSCSI data store cluster. Okay, so I give an example of NFS and VMFS. Similarly, it applicable for a separate VMFS cases also. Okay, and replicated and non-replicated data stores cannot be combined in a storage DRS. Normally, we have a two types of replications. Suppose if we see in our previous diagram, protection diagram, within our production diagram, we have a vSphere replication concept, or you can use any of the third-party array level replication, or you can use a VMware SRM, or you can use a third-party storage array replication or VMware replication. Any scenario, if you have a replicated data store or non-replicated data store, these two data stores cannot be mixed in a same data store cluster. So VMware recommendation is for all replicated data stores, create one data store cluster, and non-replicated data stores, you can create a separate data store cluster. Okay, so that is the VMware recommendation. So seventh point, replicated and non-replicated data store cannot be combined in a storage DRS. Now we'll talk about a storage DRS configuration limits. So as per our VMware configuration maximum limits, this is the VMware official recommendation. When you enable storage DRS in data store cluster, virtual disk per data store cluster is you can create maximum 9,000 virtual disks, and data stores per data store cluster, even data stores how many we can create is we can add 64. It's not like a cluster host count. Normally clusters, how many ESX hosts we can add a 96 ESX hosts, but in the data store perspective, VMware configuration maximum says that data stores per data store cluster, only 64 data stores we can add maximum. And data store clusters per vCenter, within one vCenter, how many data store clusters we added is it is a 256. Okay, this numbers normally it's useful for a VMware certified professional exam, and also the some of the interviews they may ask this limit maximum limit questions. Okay, now we'll talk about the storage DRS use cases. So in the storage DRS use cases, you can also call it as resource management capabilities. Okay, capabilities nothing but a use case. So these use cases mainly for a few scenarios. Here I highlighted a 5 scenarios. Let's talk about the first scenario. First scenario is initial placement of virtual machine. Suppose while creation of virtual machine itself, you can create the virtual machine in any one of the data store. Like you can create on a NFS data store or VMFS, vSAN, anything you can prepare during the initial creation itself. And not only creation, even the relocate, SV motion also it will require initial placement, which data store has to move. These and all it will taken care by storage DRS feature. And add new VMDK to the virtual machine. Even while adding the new virtual machine disk also, either you can create on a same data store or you can map to the different data store. That option also available. Even while creation of clone, suppose our source VM is running on data store 1 and clone VM, to avoid the network confliction, you can map the clone VM on a data store 2. So these and all taken care by storage DRS. If you have storage DRS, it will automatically placed into the respective data stores, and it uses storage vMotion to load balancing VMs based on the following metrics. So metrics we can also call it as measurements. So how the storage DRS initiate the SV motion is depends on the your data store storage capacity and also input and output latency. If any data store having input output latency, immediately it will migrate the one or two virtual machine to another data store. That is one scenario. And another scenario, even your data store is full or it is overloaded, over 80% of usage, it will migrate the virtual machine to another data store. Migrate means here it's a SV motion only. Okay, and automatically evacuates means it will migrate or it will off the VMs from a data store when we place in a storage maintenance mode. Sometimes there is some data store maintenances. For example, if you are upgrading your data store VMFS data store version from version 5 to version 6, or if you're upgrading NFS version 3 to NFS version 4.1. During this upgrade kind of scenario, we have to perform a data store maintenance mode. During this maintenance mode also, we have two methods. Either you can do manual SV motion, or if you have a storage DRS cluster, it will take care automatic migrations. Okay. And the storage DRS is configured as either manual configuration or fully automated. Same like our DRS cluster. ESXi host DRS also, we have multiple methods. You can configure as a manual, partial automatic, and fully automatic. Normally, manual method will use during the any of the maintenance scenarios, and most of the time VMware recommend to keep the SDRS and DRS in a fully automated modes. Okay. And we can create affinity and anti-affinity rules for virtual machine disk. This is also similar like within our DRS also we have a and affinity and anti-affinity. Affinity means it is virtual machine store on a together, it will store on a same data store. By default, all our virtual machines follow the affinity rule. Even VMware says that if you want to divide your virtual machine disks, let's say I have one Windows virtual machine, it has a two disk, C drive 100 GB, D drive 100 GB. C drive is dedicated for a operating system and D drive is dedicated for a data disk. We can configure anti-affinity rules for all the operating system disk create on one data store, and all your data disk you can create it on another data store. That anti-affinity rule is nothing but a separate your virtual machine file or separate your virtual machine disk also. So affinity and anti-affinity rules for virtual machine disks. Either you can make it in a within one VM disks also you can separate, or you can separate the test VM separate data store, development VM separate data store, and production VMs in a different data store like silver, bronze, and gold. Okay, so any type of rules you can configure using a storage DRS. Okay, now let's talk about the vSphere cluster lab. So lab is like a same like our previous. If you want to configure data store cluster, the minimum requirement is we require a vCenter cluster with enable with a HA and DRS features, and we need to add at least one or two ESXi host to cluster. And later we can create a data store cluster and turn on or enable a storage DRS feature. Once we turn on the storage DRS feature, we can verify all the given fully automated settings. Once we validate the fully automated settings, we can test the vSphere DRS functionality, and also we can view the vSphere storage DRS clusters resource usage. So let's jump into our lab and we'll start doing one by one. And the first one and two, we already familiar to create cluster enable HA and DRS, and adding host also we are familiar. Now I'm going to start with a lab item number 3. So if you see here, we have a 3 clusters. Okay, test cluster, production cluster, and GNAN Cloud Garage cluster. But if you select the data center, go to the right side host and clusters tab. If you see the first and second, last three clusters, I just created for our identification purpose. There is no additional ESXi host. Resources are completely empty. So we have resources only on a production cluster. So production cluster, it is running with a 4 ESXi host, and there are few virtual machines. So if you want power on, you can just power on all the virtual machines, and LCM VM power on, and also the Windows 10 virtual machines power on. So when I select the cluster, go to the summary tab, we can see totally how many ESXi hosts virtual machines we have is 8 virtual machines. Here it is showing us 1, 2, 3, 4, 5. The remaining 3 are 3 VCLS VMs, vSphere, vCenter Cluster Service VMs. So that's why it is showing the count as 8 VMs. Okay, and all are in a power on state. Now, if you want to create a data store cluster, with login to the vSphere client, we have to go to the data stores tab. See, if you go to the data stores tab, I created one temporary data store cluster. If you go to the summary tab, this is the icon for your data store cluster. Data store cluster means grouping of multiple data stores. So within this data store cluster, see, if you see there is no space, that means there is no data stores added to this cluster. In our lab data center, we have a local data stores 4, and also we have a 2 iSCSI data stores. For example, even if you want to add another iSCSI data store also, we can add. And remember that as per the VMware, if you want to create a data store cluster, minimally we have a 2 data store, and recommendation is at least 3 data stores. Okay, so even with the 2 data stores also, you can create a 1 data store cluster. Suppose if I want to add a one more iSCSI data store also, how we can add is, we already have a iSCSI configured on our Windows Active Directory system. If you want to add one more disk, let's say if you see here, the data store one is running with a how much the size 299 GB, it's close to 300 GB. And iSCSI data store 2 is running with a 100 GB. Suppose if I want to add additional 100 GB, let's make it as a complete 500 GB of iSCSI data stores. If you want to make that, first log into our virtual machine. We can increase our data store. So how we can increase? Right click the virtual machine, edit settings. You can add a hard disk. So click on add hard disk, SCSI hard disk. Let's say I am just adding the hard disk as a additional 100 GB. So now click on next, next, finish. So disk is added. Now log into the Windows operating system. We can create a another iSCSI shared. So if you want to see the iSCSI data stores, let's say here we have a one C drive 50 and another one 400. Within the 400, only 300 we utilized for the iSCSI and 100 GB utilized for a iSCSI data store 2. And I'm going to create a new volume for iSCSI data store 3. So if you want to create data store volume first, log into the disk management, disk mgmt.msc. When we log into disk management MC, you will find a unallocated 100 GB. Just now we added. So right click the virtual specific disk, click bring it to online, and later you can just initialize the disk. Click on OK, and it is completely showing as unallocated. You can just create as a new volume. Okay, I'm creating the new volume as G. Click on next and perform a quick format. Click on next, finish. So we created a new volume, which is the volume name is G. It is also with 100 GB. So this 100 GB, if you want to make this as a iSCSI share, log into our server manager. Let's close the disk management consoles and open the server manager wizard. So server manager. When you open a server manager, we can look for a iSCSI folder. Let's say here we have a file and storage devices. Just click on file and storage devices. You will look for a iSCSI. So there is a iSCSI. Currently, there are 2 data stores created: iSCSI data store 1, iSCSI data store 2. Now we are going to create a another iSCSI data store. So just right click here, new iSCSI virtual disk. While creation of new virtual disk, let's say E and F we already in used. So let's select the another drive as a new drive G, which is G letter. Okay. Now click on next, and the name you can use any of the name. Let's say iSCSI, same naming convention I'm following. iSCSI data store 03. So I created a new iSCSI data store, and description anything we can write. Now click on next. So size we are going to assign as a complete 100 GB size and dynamically expanding. Click on next. Now click on next, click on create. So it is going to create a iSCSI disk virtual disk. So virtual disk creation is completed. Now click on close. So in our Windows iSCSI already configured. Now log into the Windows our vCenter server. This iSCSI data store 3 will not add here because it's configured just now. So in order to apply the changes, what we have to do is we have to go to the configure tab, storage adapters. We have to do a rescan storage. So when you do rescan storage, it will automatically add iSCSI data store 3. So go to the configure storage adapters, click on rescan. So it will rescan for a virtual machine storage devices and also for new VMFS volumes. So rescan is in progress. If you see in our recent task, you will see rescan VMFS, rescan all HBS are completed. So let's minimize this and go to the data store tab, and here it is not showing the data store 3. So that means we can create a data store 3 manually. So if you want to create manually, just go to the actions tab, look for a create new data store option. So data store option, storage and choose for a new data store. So when you select new data store, VMFS, NFS and vValue. Normally for disk and learner comes under the VMFS only. Even iSCSI data store comes under the VMFS. So you can select VMFS, click on next. See, now you can look for our latest drive 100 GB. So select 100 GB disk and the name, if you want to keep the same name, we can keep the same name. iSCSI data store 3. Okay, now click on next. See, we are choosing the latest VMFS version instead of old version. So click on next. We are going to apply the complete size and the block size minimum is 1 MB. Okay, so now click on next. See, the summary it is showing as data store name, iSCSI data store 03, and the disk LUN it is showing all the iSCSI name, and this is the iSCSI name disk LUN naming convention, and also the VMFS version 6 100 GB it is going to add. Now click on finish. So when you click on finish in our recent task, it will shows disk addition status is completely or not. See, create VMFS data store, it is showing as completed. So when the data store creation is completed, now go to the data stores tab and see that there is a iSCSI data store 1, data store 2 and data store 3. But when you select the ESX02, it's come automatically. Okay, because it started discovering. So even ESX3 data store 3 added automatically. ESX4 also, if it is not added automatically, what we have to do is go to the configure tab, storage adapters, rescan storage. Okay, now click on OK. When you rescan, it will add automatically. See, data store 3 is added here. Okay. So like this, we can add a additional iSCSI data store or additional VMF, FCSAN VMFS data store, anything we can add. Now we are going to create a data store cluster using these 3 data stores. So how we can create? Go to the data stores tab and here select the data center, right click here. You can look for a new data store cluster. So go to the storage. Under the storage, we have option to new data store cluster. Okay, so data store cluster is nothing but a grouping of multiple data stores. So select new data store cluster. When you select the data store cluster, the default it is turning on the DRS feature. Either you can turn on or turn off. So if you turn off means it's completely manual method. If you turn on means it's a default option is automated, fully automated storage DRS. And the data store cluster name, you can keep the same name or you can modify the name. Let's say data store name is data store cluster 01. When you select the data store cluster 01, you can see the description here also, whatever we discussed in the slide, the same description. vSphere Storage DRS enables vCenter Server to manage data stores as an aggregate pool of a storage resources. Okay, vSphere Storage DRS also enables vCenter Server to manage assignment of virtual machines to data store, suggesting placement. Suggesting placement is nothing but when virtual machine are created, migrated, cloned, and also migrating. This is nothing but a initial placement, and also mainly for to balance load and enforce placement rules. Rules is nothing but the affinity and anti-affinity rules. Okay, so here also VMware given a clear description for data store cluster. So when we are creating new data store cluster, remember we need to turn on the storage DRS feature. So once the storage DRS is turned on, click on next. And it is all, if I just quick back, it is showing the location is only for one data center location only. It's not allowed to provide the storage DRS access to other data center. It is limited to within a data center. Now click on next. See, this is the important point. Same like our DRS, how we verified the DRS, all the settings, the same way here. Storage DRS automation. So cluster automation, we have two methods. No automation, that means manual mode, and fully automated. Fully automated means files will be migrated automatically to optimize clusters resource usage. Okay. So when you select this option, remaining all the options are set it as a use cluster setting. Use cluster setting means whatever you set on a cluster level fully automated, the same thing applicable for remaining. Okay, suppose in future, if you want to modify any space, space load balancing automation level, if you want to modify, you can just select the drop down menu. You can able to change it to manual, fully automatic. That means the specific option also we have an option to change it to manual. Okay, or else if you leave it use cluster settings means it by default all apply as a fully automated. And the space balance means it is nothing but a load balancing. Okay, let me move this side. Action, storage, new data store cluster. Okay, data store cluster -01. Fully automated. When I select this option, it's clearly saying that when we enable the storage DRS, the space load imbalance in a data store cluster. In case of any imbalance in our data store, it will automatically migrate the virtual machine. Even the IO balance, IO means input output balance. For this one also, IO load imbalance also, it will automatically correcting. Correcting means it will migrate virtual machine from one data store to another data store. And not only IO and space, there is additional options is rule enforcement automation level. Rule enforcement means either affinity rule or anti-affinity rule. Okay, this is also you can have an option to set manual and fully automated. And also policy enforcement automation level. Even policy is nothing but a during our software defined storage, we talk about a storage policy based management, SPBM. The same concept, whatever the storage policies you have, like silver, bronze, and all, those also it will, even though if you have a storage policies, there will be no impact for your storage vMotions from one data store to another data store. Okay, even if you want to make the storage policy to manual, we have a facility to set it to a manual. Okay, so same point you can find from the help also. Okay, so VM policies, whatever policy we have violations, those policies also we can use. And VM evacuation, evacuation is nothing but during the maintenance scenario. Even maintenance scenario also, you no need to perform a manual storage vMotion. When you set it as a same as cluster setting fully automated, it will take care of all the migrations. So this is the default storage DRS configuration options. So now click on next. There is a some additional storage DRS runtime settings. So this runtime settings more onto the input output related metrics. Okay, one is, yeah, IO input output metric inclusion. Enable this one. Default you can keep it as a default option. And the latency threshold, default latency it's set it as a 15 millisecond. You can leave it as default. Even if you want to reduce or if you want to increase, you can reduce. VMware have a options to reduce and increase options. And even space threshold, always recommended space threshold is we should maintain a 20% buffer. That means it will still wait your threshold until the 80% reach. If your data store reach 80%, it is over 81%, immediately storage DRS will migrate the VMs from that overutilized data store to less utilized data store. Okay, so this options also default recommended options. Suppose if your customer anyone want to modify to 75 or 85, we are flexible to modify the percentages. Okay, so even the sizes wise also you can maintain, or you can maintain in the percentage. Usually the recommendation is percentages. Okay, so that is a space threshold. Now click on next. We can see select the cluster and host. Let's say we have multiple cluster, but the other two cluster there is no resources. We can choose only the production cluster. Okay, so when you select the production cluster, all your data stores resources will be added to the data store cluster. Now click on next. See what how many data stores we have? Three data stores. iSCSI data store 1, 2, and 3. And even the size is 300, approximately 300 GB, 100 plus 100. So when I create a data store cluster, the data store cluster total size is equivalent to 500 GB. Okay, so let's select three data stores. Click on next. Now you can see the complete summary information. In this summary tab, you can see data store cluster name, storage DRS is enabled, and cluster automation fully automated. That means the remaining all also same like cluster setting means it is applicable as a fully automated. And the storage IO load balancing is also enable state and space threshold is 80% and IO latency with default value we are using 15 milliseconds. And the data stores is going to come added to the data store cluster is 3 data stores, which is iSCSI data store 1, 2, and 3. And the VMFS version is 6 only. We are using latest VMFS version. And the cluster name production cluster 01. All data stores are added, and even the data stores are selected. And IO load balance also capable. Yes. Okay. Now click on finish. When you click on finish, in the recent task, you can notice that data store cluster creation is completed. When you see here, configure storage DRS completed, and also the move data stores into data store cluster. Okay, these two are completed. Even if I expand the data store cluster, you can see data stores are there are 3 data stores, and even the total size is approximately 500 GB. Okay, so even current usage is only less usage, 63.9 GB is used and 435 GB is free. Okay, so you will see the clusters summary tab, all the information, even the storage DRS automation level, you can verify from a summary tab. If I expand, just scroll down below, you will see how many virtual machines. If you have any custom attributes, you can find here. Okay, even tags present, we do not have any specific tags. Generally, tags and all will use during the segregating the data stores with a silver, bronze, and also the gold. During that time, we can prepare a separate tags for each data store type. Okay, and when we create a data store cluster, go to the monitor tab. Here in the monitor tab, you can monitor the storage DRS recommendation status. Suppose if you see here, just now we created, there is no monitoring information. Even if you want to run the storage DRS one time, you can just manually run the storage DRS. It will analyze the storage DRS status. But normally, if there is no VMs or any issues, there will be no impact here even when you run a storage DRS now option. Okay, and if there is any false on the storage DRS, you will find the false. Okay, and it is showing as insufficient information during evacuation because we are using a lab virtual nested ESXi host. That's why you may expect this error, but in the real production scenario, you may not expect any of the DRS faults until unless there is a real hardware issue. Okay, and even in the storage DRS history, currently there is no SV motion initiated. It will initiate only in case of storages are overloaded. Okay, now we'll talk about some additional options in data store cluster storage DRS. Go to the configure tab. When you select the storage DRS, right side you can see there are 3 options. Storage DRS automation, just now we configured all these options, and even IO metrics, just now we configured advanced options also we have. So these settings we verified, and even you can see check the imbalance every 8 hours. Okay, and VM overrides. Even in our DRS concept, we have a VM overrides. The same concept is available in a data store cluster also. If you want to add any VMs in a overrides, you want to modify the specific virtual machines to excluding from data store cluster and all, you can able to do the VM overrides. Okay, when you click on next, here we have a option storage DRS automation level. If you want to override and change it to the disable, or you can change it to manual. Any option you can choose, depends on the customer's requirement. And not only the specific virtual machines, we can also change the virtual machine disk types also. Even the specific even one virtual machine have multiple VMDKs. One VMDK disk you can store on local disk, and another VMDK you can change the, instead of together you can set to no. That means the data disk will be stored on a another data store. Okay, these options are available in a VM overrides. So let me cancel. Now similarly, we'll verify the rules. Rules also similar like a DRS rules, affinity, anti-affinity. Even storage DRS also have a rules. So these rules also we can set any of the rule name. For example, 01. You can create a anti-affinity rule. Anti-affinity rule mainly for virtual machine level, or you can set a anti-affinity rule for VMDK layer. Suppose if I select VMDK anti-affinity, because affinity is by default, all the virtual machines are affinity rules only. Okay, now click on add. Here you can add your specific virtual machine. So testing purpose, I selected here Windows 10 VM. Click on OK. When you select one virtual machine, the rule is going to enable and it is configured as a anti-affinity rule. When you click on OK, obviously this virtual machine is having a anti-affinity. That means all virtual disk of the listed virtual machine should be placed on different data stores. Suppose this VM have two virtual disks, one disk on one data store and another disk on another data store. That is the importance of anti-affinity rule. Okay, so this is about the storage DRS rules. Now alarms, even we have a default alarm in case of any data store cluster issue. Immediately vCenter server itself, it will generate a alarm. Okay, and a scheduled task, even if during your storage data store migrations time, you can data store maintenance scenario, you can schedule the some of the tasks. This schedule information you will find only when you select the storage DRS. Here in the right side, even if you want to modify in future any of the metric, click on edit and we can modify the storage DRS settings, runtime settings, and also the advanced options. Even this 8 hours, if you want to customize, we can customize, but default recommendation from VMware is 8 hours. Suppose these settings, if you want to schedule anything, schedule a storage DRS, just click here. Suppose I want to run a storage DRS schedule for any of the frequency, like once, or you can run for after vCenter startup, hourly, daily, weekly. For example, I selected as a weekly. And weekly also, if you want to run on Saturday or Sunday or either weekend or week beginning, anytime you can choose. For example, I select as a weekend Sunday. When you select the Sunday and schedule the storage DRS running time on weekly task, now click on next. And in the next, we are going to enable a storage DRS option. Now these options are same like our previous discussion. Now click on finish. When you click on finish, it is going to schedule a storage DRS for every Sunday. So that information you will find from a scheduled task. Okay, so configure storage DRS. It's already configured for a schedule to run every weekly once. Okay, it's a kind of schedule also we can configure. Even if you select this, if you want to edit, you can edit in future, you can remove, you can run. Any option we can perform using the data store cluster, configure, and schedule task. Any data store cluster level schedule task, we can schedule it. So we verified the, let's back to the slide. We verified how to turn on the storage DRS, how to create a data store cluster, and we tested the where we can run the storage DRS functionality. Storage DRS functionality, if you want to run, go to the monitor tab, recommendation, here we can run. Okay, and also the view the storage DRS cluster resource usage. The resource usage we can find from a summary tab. How many data stores we have, what is the resource usage. Currently, all our the 3 data stores are running with a less resources. Even suppose in future, if you want to add it to your local data, so all local data store, you want to make it one data store cluster. That means each ESX host have a multiple local data stores. That scenario, you can just drag and drop it here. It will add it to the ESX. Just for testing purpose, I'm adding ESX to the local data store, but in the real time scenario, different host local data store not recommend to add on a one cluster. But normally adding procedure very simple, just drag and drop it here. So same way third, drag and drop, here also drag and drop. But even in order to perform the storage vMotion, this data store must access to the multiple ESX, but there is no other ESX host access. So it will migrate within the data store only. It won't migrate to other data store. Okay. So even if you want to move out from this cluster, data store cluster, just expand here, drag this data store and drop it on the data center level. Like that, we can move out also. Okay, it's a just simply logic feature only, drag and drop. For data store maintenance options, for example, right click the data store, you can look for a maintenance mode. This maintenance option we can do only during the any of the upgrade scenarios like NFS version upgrade, VMFS version upgrade, or physical storage array level. Your storage team is going to do some maintenance. That time also we can use this enter maintenance options. Okay. So even if you want to remove in future, just unmount first and then you can go for a delete data store. Before delete, remember we have to unmount. Okay, this unmount will help you to remove the data store from all your ESXi hosts. And then you can just right click the data store and delete data store. Okay, so this is the storage DRS topics. So if you have any questions, let me know. and let's quickly update our master checklist. See, we are almost closing the main key features in the cluster. So today, by today's session, we completed the all vCenter cluster features, HA, DRS, and storage, DRS, fault tolerance, EVC, and DPM. Okay. So in our that's it for today. In our next session, we may plan to discuss on license management or resource or content level. Any one topic I will start, and later on, all are the very small topics only. One important topic is lifecycle manager also. Okay, the remaining topics are very simple topics. We can finish it. And resource pool, life cycle, the four key concepts we have. Okay, once this is finished, all our vCenter features are completed, and then we'll go for a vCenter, a vSphere 7 advanced features like vSphere with the Tanju, vSphere with uh, Kubernetes also we have. Tanju means it's a Kubernetes advanced technology name. It's developed by VMware. Okay, so vSphere with the Tanju we can discuss, and also the some of the additional features of advanced features we can discuss. Okay, workload management is nothing but a vSphere with Tanju. So that's it for today. If you have any questions, let me know. If no questions, we can end the session here. Thanks for your time.
Thank you.
Yeah, thank you. Bye for now.